Hi everyone, in this video we'll discuss about the arithmetic mean and geometric mean and problems which include the inequalities of arithmetic mean and geometric means. Now this chapter is very important in terms because many of the inequality can be solved by using arithmetic mean and geometric mean, and it's very important in respect to the competitive exams. Now what's all about the arithmetic and GM equality? The most basic arithmetic mean and geometric mean inequality states that simply if x and y are non-negative real numbers, or you can say that r plus, then x plus y upon 2 is greater than equal to under root of xy. Says that x plus y upon 2 is arithmetic mean and under root of xy is geometric means. Arithmetic mean, here this is arithmetic mean, is greater than equal to geometric means. Condition here is x and y should be non-negative real numbers, that is r plus categories, right? Now let me give you the proof of this thing. X plus y upon 2 is greater than equal to root x. If I say this x plus y upon 2 minus root xy, let me calculate here. X plus y upon 2 minus root x is can be written as half of under root of x minus under root of y square. Now square of any number is always gives you a positive thing, and half is a positive thing. That means the value here is positive or can be 0. It means generally we can say that says that root equality holds. Now important thing is equality holds only if x is equal to y. Or you can say arithmetic mean equal to geometric means only if and only if x is equal to y. Or if x is equal to y, we can say arithmetic mean is equal to geometric means. That means vice versa. Or says that or implied by or implies is, right? So whenever we get the value under root of xy is equal to x plus y by 2, it means this means x is equal to y, right? Now this is the proof. Now if we generalize this theorem for the n numbers, let me generalize it. Arithmetic mean of n number is, let's say, x1 plus x2 plus x3 up to n. Arithmetic mean here we divided by n, right? Now geometric mean of the n number is x1 into x2 into x3 up to xn raised to power 1 upon n. It says that arithmetic mean is greater than geometric mean. That means this quantity is bigger than this geometric. Now if you need the proof of this n numbers, let me generalize it more. You know that p plus q upon 2 is greater than equal to root pq, right? We've just started now, we've just given the proof. Let's say r plus s upon 2 is greater than equal to root rs, right? Now let me take out the geometric mean of under root of pq plus under root of rs. Arithmetic mean of this is under root of pq plus under root of rs by 2. This is greater than geometric mean. Let me calculate the geometric mean here is, this is a, this is b, and raised to power 1 by 2. These are the two numbers. Now this is under root of pqrs raised to power 1 by 2, or in other words I can say pqrs raised to power 1 by 4 is greater than equal to under root of pq plus rs upon 2. Now if I add these two equations, because these two we have said that the numbers are positive, this will not make any difference because this is positive, this is positive. If we add this, there is no change in the inequality sign. Now if we add this p plus q plus r, now this under root of pq under root of rs upon 2 is obviously greater than p plus q plus r plus s by 4, because here it was true. Now we have proved that p plus q plus rs upon 4 is greater than equal to pqrs raised to power 1 by 4. We have proved for the 4 number. Now we can go for the beyond 6, 8 and 10, 11, 12. Now this is the process. That means by default arithmetic mean is greater than geometric mean, right? So in conclusion we can say arithmetic mean is summation of n equal to 1 to n ai upon n, and geometric mean is pi I equal to 1 to n ai raised to power 1 by n and says that arithmetic mean is greater than equal to geometric mean. And again, equality only holds, equality holds when all the terms, that is ai, is same. That means for all values, that means a1 equal to a2 and a3 and so on up to a. This is a generalized thing, right? Let's come to the problem here, because here is the problems are more important. How to solve the problem using am and gm. The question is, prove that a plus b, b plus c, c plus a is greater than equal to 8abc. Now using the a and gm, how can we prove that? We know that a plus b upon 2 is greater than equal to root ab. We just studied now, arithmetic mean greater than geometric mean, right? Similarly, we can say b plus c upon 2, arithmetic mean is greater than geometric mean. Similarly, I can say c plus a upon 2 is greater than equal to under root of ca. Now these all are the positive quantities, because we are using the arithmetic mean and geometric means. Given that these quantities are positive, it's also given these quantities are positive. Now if we multiply all this quantity from the LHS side and from the RHS side, it gives me, I multiplied all the quantities at LHS and all the quantities at RHS. It gives me a plus b by 2 into b plus c by 2 and c plus a by 2 is greater than equal to under root of ab into bc into ca. Right. Now ab bc ca means a square, b square and c square, that is greater than equal to abc. This quantity is equal to abc. Now I can say easily a plus b into b plus c into c plus a. From here 2 into 2 into 2 is 8 is greater than equal to this quantity is abc. Now it means a plus b into b plus c into c plus a is greater than equal to 8abc. Remember this thing also, because it's very good in qualities. Sometimes you can use it directly in the problem in the objective. Let me explain one more problem here. A plus b plus c is 2 and given a b c is real plus. If we assume in all the problems of a and gm all the quantities are positive. Prove that ABC is greater than equal to 8 times of 1 minus a into 1 minus b into 1 minus c. Now solution of this problem. A plus b plus c is 2 and we have to prove that ABC is greater than 8 times of 1 minus a, 1 minus b and 1 minus. Let me assume 1 minus a equal to x, 1 minus b assumed to be y and 1 minus c assumed to be c. Okay? Tick. And therefore by condition, these conditions and this condition, I can say that c is equals to x plus y, b equal to x plus z on solving, and a equal to y plus z. Right? Now let's put this value over here. Value of abc, value of abc becomes now x plus y into y plus z into z plus is greater than equal to 8 times of 1 minus a is x, 1 minus b is y and 1 minus z, 1 minus c is, this is the identity. We have just proved this identity by using the AMGM. If this holds true, that means this holds also. It's the same thing now, because we just proved this quantity. So by AMGM we have solved this complicated problem. It's all about visualize how to solve the problem. Let's come to the more complex problem here. Let's come to the more complex and most interesting problem. A4 plus B4 raised to power 4 plus C raised to power 4 is greater than equal to ABC bracket root AB plus root BC plus root CA. Now we have to prove that A4, B4, C4 is greater than equal to ABC under root of AB plus BC plus CA, where A, B, C are real plus. Now it's again very difficult to visualize how to solve this problem using ANG. Now let me teach you the way how to analyze it. Now this is the root ABC, root AB, root BC, root CA. Now obviously in GM all quantities are the product form and the AM all the quantities are summation form. Here is a summation, but again you are getting a summation thing. Let's solve this problem here. ABC root AB, right, plus ABC root BC plus ABC root CA, right? Again we are not getting how to solve the problem. Now can we again say that this quantity can be written as under root of A square into A is A cube, B square into B is B cube, and under root of C square. You can write this in this way, or this quantity can be written as under root of A square B cube C cube and plus under root of a square into a cube, b square and c square into c. Now again I am not able to visualize it. Now see here, this is a cube b cube c square under root. Now a cube b cube c square under root of this quantity. Imagine how we will get this kind of a quantity in GM. Apply the A in GM. This is a cube. That means a has been multiplied 3 times. That means, can I say this is 3a4 plus 3b4 and 2c4 upon 8, because 3 plus 3 plus 2 upon 8. This is AM is greater than GM. GM means A4 into A4 into A4 3 times, then into B4 into B4 into B4, that is 3 times, and to C4 into C4 raised to power 1. Right? This is AM is greater than equal to GM. We have to somehow transform these values from here. Now let's see what it gives here. A4 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 B4 B4 and C4 C4 and by 8. Can I feel it? This is somehow quantity. This is everywhere is 4. Let's cancel with the 4 with the 2. We left with the a square, a square, a square, b square, b square, b square, and c and c. Now can I say that this is under root of a cube, b cube, and c square? Now you can say that, see that these two quantities are same. Wow, what's wonder here? Now can I say that 3a4 plus 3b4 plus 2c raised to power 4 upon 8 is greater than equal to under root of a cube, b cube, and c square, or in other words, this quantity is equal to under root of this quantity is equal to under a cube, b cube, c square is, this is abc under root of ab, right? Now this quantity is this quantity and this is this quantity. We got the first quantity here. Similarly for second quantity, I can say that 2a4 plus 3b4 plus 3c4 upon 8 is greater than equal to, now this is 2 here, I can say abc under root of bc will be and c. Now similarly we can use the third thing, 3a4 plus 2b4 plus 3c4 upon 8 is greater than equal to abc under root of ca. Now we got the 3 equations. If we sum up these 3 equations here, if we sum up the 3 equations, means 3a4 plus 2a4 plus 3a4, 3 plus 2 5 plus 3 8, again 8, again 8, 3 3 2 2 3 3 8, and here is a quantity which it has to be proved from the RHS side. It's always the same quantity, this quantity, right? Now adding on this all quantities, we get the 8 times of a4, 8 times of b4, and 8 times of c4 upon 8 is greater than equal to quantity which we have to prove, the abc root ab plus root bc plus root ca. Now this 8 we cancel with all the quantities, and hence the answer is a4 plus b4 plus c4 is this abc root ab plus root bc plus root ca. And this is the way we have solved the problem. Now I understand this was a complicated problem. You have to analyze this. Just check it out how we have solved this problem. A4 b4 c4 is greater than abc root ab root ca. Whenever we get the positive some sum of signs, split it out into the product in the separate ways and try to get each quantity in the AMGM form. Try to get each quantity in the AMGM form and add them in the final version, right? And I promise to get with the more difficult and more complicated problem in the next video. Wait and watch and try to find the next video in your library. Thank you.